American Meteorological Society's policy program is supported in part by a public-private partnership.
We're also looking to do a one-stop shop where someone can come to one location, see the hazard, see the risk, determine what type of mitigation strategies can be done. Oh, and I'll show you, we're also able to calculate insurance rating.
John Dorman is the Assistant State Emergency Management Director for Risk Management. He is responsible for implementing a statewide risk management framework for natural, accidental, and intentional hazards. He also directs the North Carolina Floodplain Mapping Program and is the chair of the National Technical Mapping Advisory Committee. John.
Well, good afternoon. Hope everybody's doing well. Hello from North Carolina. We have beaches, mountains. We love your sales tax money, so come see us. But yeah, I was asked to really describe what is the possibility that's already in place. You know, a lot of discussions happen on the Hill about what can be done, what technologies are out there. And let me just say right now, the technologies are in place to really go to the cutting edge, to the next generation of what floodplain, or what I'm calling flood risk management. And I say flood risk management because it's not just the identification of the hazard, but it's the structure-based risk, the mitigation, and the insurance that associated with that. All those components have to work together. So I'm gonna try to give you a real quick understanding before I get the plug pulled on me, and so let me see how we do. So just very quickly about North Carolina, you know, Hurricane Floyd is what kicked off for us. In 2000, we realized, as most people do, that their maps are outdated, the elevation data is outdated, and so we started what is phase one. Phase one lasted about 8 years, and our main emphasis there was flood hazard identification. What we have in North Carolina is a seamless flood theme across the whole state. It does not stop at any county or municipal line because we decided that it would be a seamless structure. We've studied over 30,000 stream miles of study with new topographic data that I'll show you, and that allowed us to do limited detailed studies because the elevation data was accurate enough. So then in 2001, we stopped and we said, all right, let's scratch our head and figure out what we need to do next. Well, by having the foundation of elevation data and having the foundation of the flood data, we felt like we would move into what is a digital flood risk management approach at the structure level. You know, we many a times convey you're either in and out of that line, but how about the building itself? And so what we've been doing since 2008-9 up until 2018, we are actually assessing what is the flood risk by structure, every structure in the floodplain. And we do not make cartographic maps anymore. We do not draw maps. We have a database that defines a template that conveys every bit of that information, and I'll convey that. And then as of 2015, we have also started moving into what I think is risk communication. You know, when you tell somebody you're in a 100-year floodplain, or even more so when you tell somebody you have a 1% annual chance, their eyes roll back in their head. We're trying to work on how to communicate better someone's risk, but we're also looking to do a one-stop shop where someone can come to one location, see the hazard, see the risk, determine what type of mitigation strategies can be done. Oh, and I'll show you, we're also able to calculate insurance rating now. So this is just a graphical slide of what I've just said. We've been progressively collecting data that builds our flood risk system. We've been collecting a significant amount of framework data. We've done the flood studies. We've gone completely digital. We've been collecting a lot of exposure data about living and built structures. We've been doing flood risk management on the structure-based. I will also say, once you've got this framework in place, you can do it for all hazards, and we started doing that in North Carolina. We've then taken insurance information. We've used the rating models that FEMA uses, and we are now able to actually provide a range of what an insurance rate would be based on risk. This is just a little bit of elevation data, and I'll talk about it in just a minute. I was understanding that not everybody understood some of the technology. So we are using a technology that is in place. It's been in place since the 1970s and has perfected itself, and it's called LIDAR, light detection and ranging. And basically an aircraft has a light sensor that sends out sometimes hundreds of thousands of points per second. And each one of those points has a time space to it. It hits the ground, it bounces back up to the aircraft, and it allows us to determine what the elevation is for the ground. We did this in 2000, 2003, and 2005 across the state. And the accuracy of it was at a 95% competency at a 20 centimeter accuracy, so very, very accurate at the time. This is the map. This is a very expensive map. It's about a $25 million map, so hope y'all like it. But it basically provided us a significant amount of data that for us, for the 2000 to 2008 phase one was a silver bullet because it gave us very, very accurate data. This is the same slide I showed you a minute ago. This is North Carolina laying down flat, and you can see this is the Outer Banks, and you can see the dark blue shows you how low to the water surface elevation it is on the coast, and then the light purple is actually bathymetric data that we've attached to it. That allowed us to do very strong coastal studies as well. So topographic and bathymetric data is a significant tool for us. But we've moved forward. It's been 15 years since we collected elevation data, and now we're moving into what is USGS's concept of 3-depth. I think y'all have heard of that, three-dimensional elevation for the nation, and we've been collecting that for a good bit of time. We've collected phase one, phase two, and phase three. The difference between the two is that instead of 20 centimeters to the bare earth, we're down to 3 inches. That is a dramatic increase. And it's not just a point every 10 feet, it's 2 points per square meter. And here's the thing, it's costing no more than what it cost us to do the phase one approach. So technology has perfected itself so that you can actually have a much better sense of the topography on the ground than you did 10 years ago. This is an example of that, and I just want to communicate the accuracy. You see down here at the bottom where it says actual survey elevation. That shows the stream that you see up above. Unfortunately, this is a 30-meter elevation model that comes out of USGS. It's across much of the United States. And you can see that yellow line is supposedly showing what that stream looks like. Very inaccurate. Then you have the 10-meter elevation model that USGS calculates for some. You can see that comes better, but it really does not reflect what the stream looks like. This is what North Carolina thought we were in high cotton with. We thought we were in good shape, but really we, in some cases, could be about 5.5 feet off vertically. But this new LIDAR data, the 3-depth data, it's spot on to the true elevation of the stream. And we believe this is a significant component for having much better, more accurate maps. This is another example of that. You're also able to collect different classifications of the elevation data. So while you're doing this, you can collect the streams, you can collect the buildings, you can collect anything you can imagine with this. Let me flip to the next one. This is where this same set of information has been classified to roads, bare earth, low shrub, high shrub, all vegetation, but it also identifies water sources, and it's to that 3-inch requirement. So once again, this is a big plus for us. So we, as I mentioned, have been collecting a significant amount of stream studies. We have completed the state back in 2008, did about 30,000 stream miles. We are now in maintenance phase to come back across the state. We are also updating not just the 100 and 500, we're doing the 10, the 25, the 50, the 500. What we do with it, though, is for each one of those, we create a water surface elevation. There's the technology called rasters. So someone can click on this graph, and it will tell you exactly what is the base flood elevation anywhere on that graph. That's what the raster does in the GIS field that we have today. But taking that elevation data that we had, that we mentioned a minute ago, and taking the base flood elevation for those different events, we can now start telling you how deep the water will be. And you can click any point on that, and it will give you the depth of the flooding. Then we've been collecting building footprints, and I think this is a big plus. This is not one of my child's coloring maps. This is basically 5.1 million buildings that we've taken imagery and we've drawn the building footprint for every building in North Carolina. And this has been done basically by taking the imagery and using an algorithm that basically identifies every structure, and it will make the geographic association with that. Then what we've been doing is, as we've been going out and collecting information about the building, we've also been collecting parcel data about the building from the counties. We've been collecting hazardous information about the building. We've been conflating everything back to the building. So we have a very strong understanding of every building and the value of the building, what community rating system it's tied to, what community it's tied to, and we've been conflating that all back into the database. One other thing, just to show you, just to keep y'all awake, I know it's right after lunch, hopefully he's thinking about doing it. Basically, this is a mobile LIDAR truck. This truck is basically the same thing that the aircraft was, but it's on a truck, and it goes around and it actually is collecting first floor elevations. So it drives by your house, and all of those points are hitting the side of your house, and we take that one point that is right where your livable space is. And we use that to do risk assessment, and I'll show that to you in just a minute. I will just very quickly speak to digital. And I think a lot of people think, well, right now FEMA is in the digital world because they have a PDF. That's not digital. Digital is really where all of the data that in this is a TSDN book over here on the right. It's constructed as a hard copy book, and then it's PDF. We don't do that. We take the data and we put it in the database, and then it's communicated out in a digital display. Now, if we want to print something out, so be it. But everything we do is coming directly out of the database with a template that defines the product that you need. And that has been a significant cost reduction for us, both time and energy. And these are just a couple examples. So really what we're doing is one source for all products, and it allows a very quick update on that. So here's where it gets into the fun part. We've collected all this data. So we have the topography, we know our roads, we know our parcels, we have our building footprints. Now we know the building value because we've conflated the community's value of that property back to that building. So we know what the building value is. We have cross sections from the engineering work. We then start flooding the buildings with different levels of that water surface elevation. And so what we do is we know the first floor elevation, and we subtract it from the water surface elevation, and now I know how deep the flooding is in the building. Now there are depth damage curves that says if it's this much in the building, this is the amount of damage. If it's this much, it's this amount of damage. So what we're able to do is actually start defining what the actual building damage cost is, and we can tell you tax value-wise which buildings are going to be the most impacted. And then what we can do is we already have the information about each of the buildings. So down here in the bottom left-hand corner for this property, see the information up near the top, the building value? That's all the information we've collected. Down at the bottom is the 10, the 25, the 50, 100, and 500. And you can see what the damage costs are for that building for those different events. So we are doing structure-based risk management. So then on insurance rating, this is one of the insurance industry's tables that basically calculates per $100 what the cost is for insurance. And you can see this table talks about if you have a home that's a one-story home that may be family, may be residential or other, and it starts calculating out what the cost would be for that. We've taken that set of tables, the exact set of tables, and I'll go through this somewhat quickly. All of that information tied to that building, we start plugging that information in, and by doing that, we actually can start calculating what the cost of insurance should be, or the rate should be. And so, last couple slides here. This is our website. This is the http frizz.nc.gov, not frizz hair, but frizz flood risk. You can go to our website, and this is the website. It has the buildings, it has the flood zone. Up in the right-hand corner, you get flood information, so you can see what the base flood elevation is. But then you can start looking at every building, and by looking at every building and having the characteristics of those buildings, I can tell you exactly what the damage and cost will be for the different types of events. Then you say, oh my gosh, I'm in real trouble, what do I do? Well, we've taken FEMA's mitigation strategies and we've applied them back into our model, and we can say, if you want to elevate for that building that you got, it's gonna cost you this amount of money. And is there a return on investment that's positive, 1.0? So they can start making some decisions. Communities can do the same thing. They can get information by different sectors, by different communities. They can actually click on a building and identify different strategies if they would like. And then once again, see the products around the bottom. Those are products that come directly out of the database. I'm almost done. The final thing, and this is on the insurance side, so that same building that we were just clicking on, you can see up here in the right-hand corner, now that we know if it's a pre or post-firm building, we can start defining for a monthly premium how much it would be, and as well as a yearly, and the actual individual can go back in and make changes. A developer could actually come in and click on a ground elevation and type in what type of building or what elevation, and it would give you a range of what your insurance would be. So you can start actually making good decisions for what level you think you need to build to. So are we doing it by ourselves? I just want you to understand, these 4 states are in the system. The state of Florida, we have all of their data in our database. Alabama, all of their data is in our database. Virginia is as well. They are not at the same level we are. They may just be showing the flood hazard, but they're all in the digital environment, and we're very pleased with this so that we can leverage what we're already doing. I mentioned iRisk. This is our all hazards. I'll just show you that for all of the different types of hazards, we can actually get it to the building level because it's using the exact same framework. So that was, no unplugging? Great. Okay, thanks.